Hey there, I am a disease. Allow me to explain. Life began right here on Earth approximately 3.7 to 4 billion years ago. But what if the earliest structures for life on Earth came from somewhere else? A distant world? What if somewhere far from our home lies our birthplace? This is RNA. What is considered to be the most basic molecule that has the ability to replicate itself? Scientists aren't exactly sure when, but at some point after RNA's emergence, DNA started appearing on the scene, leading to the first double-stranded molecule that would eventually form the double helix pattern which we are all familiar with today. This is important to know, because these building blocks for life may never have arrived on Earth if it wasn't for panspermia. Is the reason why we can be so confident in believing that life exists outside of Earth. It is the theory that all life came from precursors formed in outer space. These precursors are usually thought to be some chemical compositions relating to sugar. That's right, sugar is one of the most important chemical compositions when it comes to forming life, as it is found to make up ribose and deoxyribose, the fundamental structures behind RNA and DNA respectively. The theory goes like this. In outer space, bodies of rock and space sediment, such as asteroids, collect different elements and molecules throughout its travels. Over time, many of these may form the right compositions that can lead to the development of ribose, amino acids, or even microorganisms. Then the space rock reaches the end of the line, crashing full force into its final destination, scattering its matter and occupants far and wide. Until millions of years later, through many tedious changes, multicellular organisms appear and we finally have life that's capable of evolving and adapting to its environment. What I just told you could very well be the same conditions that created life on Earth, known as abstract panspermia. And if that's the case, then surely there are many more planets out there that have been bombarded with these life-developing rocks, right? It's certainly possible that this is the case. However, given that the conditions we know of for forming life so far are very specific, it's unlikely that life will exist everywhere. But before you get sad about that, let's go over the different types of panspermia. Abstract panspermia, as we mentioned before, is the formation of life before it reaches a planet. Radiopanspermia is the idea that microscopic life such as spores can be blasted through space by the radiation of nearby stars. However, the possibility of radiopanspermia was heavily criticized by astrophysicists Iolif Shklovsky and Carl Sagan. But that's a story for another time. Next, we have lithopanspermia. Lithopanspermia refers to life that has existed on one planet and been transferred to another planet. The most common example of this would be, for example, the Chicxulub asteroid that wiped out the dinosaurs, breaking off chunks of the Earth, sending them hurtling through space until they eventually hit something. And sometimes that something will be a planet, where extremophiles, microscopic organisms that are capable of surviving extreme conditions, could have survived the trip, therefore inhabiting another planet with life. This is by far the most believable explanation, as extremophiles such as the tardigrade have been proven capable of surviving in the vacuum of space. The last method on our list is probably going to be the most controversial, and that's directed panspermia, the theory that life was intentionally placed on a planet capable of hosting it by seeding the planets with basic structures of life. The idea proposed by once again Iolif Shklovsky and Carl Sagan, after they realized that humanity should be spreading life to other planets in order to ensure that if we are the only form of life, we don't become extinct. Now, to some, this may sound far-fetched, but there's a lot of merit behind this way of thinking. Even if there's no other life out there, we can become the sole progenitor for all life in the universe. As long as we get our DNA structures out there, there is potential for them to grow in all sorts of environments. There's just one problem, though. As I mentioned earlier, I am a disease. Now I'll explain what I mean. If we send a rocket or spacecraft of any sort to another planet in hopes of spreading life to it, we may inadvertently spread harmful viruses and diseases to these planets, which could already contain life with zero immunity to Earth ailments, effectively wiping out that life form altogether. We are all diseases. The moment we leave Earth, we endanger any potential life out there in the universe. After all, our bodies are filled with bacteria unbeknownst outside of our home. What is the point of looking for extraterrestrial life if our very presence is a danger for it, or if its presence is a danger to us? At the end of the day, our technology is always improving at a fast pace with all sorts of innovations being made each year. I'm sure that by the time we get to that point, we will have an easy and efficient way of completely sterilizing ourselves for the upcoming missions, but for now, our blue marble will remain our home.